Hello friends, today I will give you brief notes on proteolytic enzyme as well as chemical digestion of polypeptides. We all know that polypeptide chains can be identified via sequencing. But if the chain is long, for an example, sometimes it is greater than 50 kilodalton units, then it's difficult to identify them via sequencing procedure. So what they do now, they will make a smaller fragments of polypeptides, and then after they send them for sequencing, and these fragments can be possible via certain proteolytic enzyme digestions, and these enzymes can determine specific location present on polypeptide chain and then cleave accordingly. So specificity of all the proteolytic enzymes cannot be same. Means each and every enzymes can work in a different fashion, and it depends on sometimes side chain amino acid present in polypeptide chain. So this polypeptide cleavage can be done via two ways. First is chemical digestion, as well as second is proteolytic enzyme digestion. In chemical digestion, cyanogen bromide is used, that denotes as in CNBr. And what is the mode of action of cyanogen bromide is it cleaves polypeptide at a specific location. If methionine amino acid residue is present in particular polypeptide chain, then cyanogen bromide cleaves after every methionine residue at the C terminal of the polypeptide chain only. Okay, then the second chemical is hydroxylamine. Hydroxylamine cleaves at if asparagine and glycine residues are present in polypeptide chain, then it can be cleaved by hydroxylamine. Then second way is proteolytic enzymes. So this is a basic figure of, for an example, polypeptide chain is given, and this is a target polypeptide bond that we want to cleave via enzyme. So C terminal cleavage of this peptide bond can be done via proteolytic enzymes, and Rx denotes as the amino acid present after the target peptide bond, and Rx minus 1 represent the amino acid present previous the targeted peptide bond. Okay. So now the first enzyme is trypsin. Trypsin is a kind of enteropeptidase. So enteropeptidase work on somewhere in the middle of the polypeptides. So enteropeptidase never work on terminal amino acid sequence cleavage in the polypeptide chain. So please keep in mind. And so mode of action of trypsin is it cleaves at carboxyl side chains of lysine arginine residues. We all know that lysine and arginines are the basic amino acids, but the condition can be if next proline should not be present, and next amino acid I already mentioned you this represent as in Rx. So Rx should not be a proline. Then and then if lysine and arginine residues are present, then trypsin can cleave at the carboxyl side chain of lysine as well as arginine residues. Okay. Then the second enzyme is chymotrypsin. Chymotrypsin again work on specific aromatic amino acids. We all know that aromatic amino acids are phenylalanine, tyrosine and tryptophan, right? Then chymotrypsin cleaves carboxyl side chain of this aromatic amino acids, but the condition should be next proline should not be present, next amino acid should not be proline. Then and then chymotrypsin will come and work on aromatic amino acid side chain cleavage. And the third endopeptidase is pepsin. Pepsin cleaves at amino side chain of aromatic amino acids. So the mode of action of pepsin is exactly opposite to the mode of action of chymotrypsin. So these aromatic amino acids are phenylalanine, tyrosine and tryptophan, but the condition should be previous amino acid should not be in proline. So the sign for previous amino acid is Rx minus 1 should not be proline. Okay, so please keep in mind. The fourth one is elastase. It's an endopeptidase that cleaves carboxyl side chain of alanine, glycine as well as serine amino acids. But the condition should be, again, if next proline is present, then elastase will not work. So Rx should not be in proline. Then and then if alanine, glycine and serine amino acids are present, elastase will come and cleave carboxyl side chain of these amino acids. Okay. Then the second class is exopeptidase. Exopeptidase work only on terminal amino acids, not somewhere in the middle. If terminal amino acid cleavage we should cleave, then and then exopeptidase will work. So the class of exopeptidase are carboxypeptidase as well as aminopeptidase. The first one is carboxypeptidase. So carboxypeptidase basically remove terminal amino acids from the carboxy terminal end of polypeptides, and the subtypes of carboxypeptidase are carboxypeptidase A, B and C. A will work only on carboxy terminal side, except proline, lysine and arginine. So all amino acids which are present in carboxyl terminal side can be cleaved by carboxypeptidase A, except proline, lysine and arginine. Okay. Whereas carboxypeptidase B will work exactly opposite to carboxypeptidase A. If proline, lysine and glycine and arginine, only the amino acids are present at the carboxyl side chain of polypeptide, then and then it can be cleaved by carboxypeptidase B. So the action of mode of action of carboxypeptidase A and B are exactly opposite to each other. Now carboxypeptidase C can act on all the C-terminal amino acid residue cleavages. Okay, and the second class is aminopeptidase. Aminopeptidase, as the name suggests, cleaves from amino terminal amino acids of the polypeptide chain. So there are no any exceptions for specific amino acids. All amino acids present at the amino terminal side of polypeptide, then these all amino acids can be cleaved by aminopeptidase. Okay. Now if amino acid polypeptide chain can contain more than 2 or 3 disulfide bonds, then it is necessary to also cleave disulfide bonds. Okay, then disulfide bonds can be cleaved via some chemicals. We all familiar about it, right? That is urea and guanidinium hydrochlorides are basically used, and oxidation and reduction of disulfide bonds can be carried out via some chemicals. Disulfide bond can be oxidized in the presence of perphoric acid, and it will give rise to two cystic acid residues which are acidic in nature. Then after reduction of disulfide bond is again carried out via beta mercaptethanol, and the second chemical I forgot to mention, that is dithiotetrol. It produces two cysteine residues. Okay, but there are chances that thiol group, that are SH group, are present in cystic acid as well as cysteine residues, can again reform disulfide bond. So to avoid this problem, acetylation of this free SH group can be carried out by in the presence of iodoacetate chemical. So in this way we can prevent reformation of disulfide bond. So I hope these notes will help you. If my videos are helpful,